All right, let's jump right in. Today, we're going to go deep underground to explore one of the most surprising stories in clean energy. We're talking about how the very same coal mines that powered our industrial past could actually become the clean energy hotspots of our future. This quote, it really hits home. It's from a former miner, someone who spent 21 years down in the pits, and it just perfectly captures what this is all about. It's this idea of turning a symbol of pollution into a source of redemption. So that's the big question for today, right? Can we really take the dirty infrastructure of yesterday and repurpose it to power the clean world of tomorrow? Well, the answer isn't just yes, it's that it's already happening. Let's dig in and see how. Okay, so first things first, we've got to understand the problem we're trying to solve here. The legacy of coal isn't just about smoke and carbon emissions. It's literally scarred into the landscape and the communities built around it. Just listen to how one former miner described his job. It paints a pretty brutal picture of life underground, doesn't it? This was an industry that built empires, yeah, but it came at a huge human and environmental cost. And when the mines closed, they left a lot more than just memories behind.
And here's where you really see the two sides of the coin. What was once the engine of an entire empire is now, in a lot of places, just a massive liability. See, the mines didn't just vanish, they filled up with water. This mine water can poison drinking water, and for over a century, waste from the mines was just dumped right onto beaches, creating what one local called a scar on the environment.
Okay, but here's where the story takes a fascinating turn. That flooding, that big environmental liability, well, it turns out it's sitting right on top of an incredible, totally untapped energy source. And it's all thanks to some basic science about our planet. The key thing to get is that you don't need volcanoes to have geothermal energy. Not at all. Pretty much anywhere on Earth, the deeper you go, the hotter it gets. It's called the geothermal gradient, and it's surprisingly consistent. And check this out. It shows you just how fast that heat builds up. Go down just 1 kilometer, and the rock temperature is already a pretty warm 40 degrees Celsius. Go down 5 kilometers, and you're looking at a toasty 140 degrees. There is just a vast amount of heat sitting there, right under our feet. So where is all this heat coming from? Well, get this, about 20% of it is literally leftover heat from when the Earth was just a molten ball of rock 4.5 billion years ago. But the other 80%, that comes from the super slow radioactive decay of elements like uranium and thorium in the Earth's crust. Our planet is basically a giant, slow-burning nuclear battery. Now, here's a really important point. We're not trying to get water boiling hot to run steam turbines and make electricity. Nope, this technology taps into what's called a shallow geothermal, using the consistently warm water that's just a kilometer or two down, and that is perfect for the UK's single biggest energy demand, heating. Okay, so we've got flooded mines sitting on top of a natural, constant heat source. So the question is, how do you turn that problem into power? Well, the process is actually ingeniously simple. So here's the play-by-play. First, those old mine workings, they just naturally fill up with groundwater. Then, the Earth's geothermal heat warms that water up to a steady 20 degrees Celsius all year round. From there, we pump that warm water to the surface, run it through a heat exchanger to pull out all that warmth. And finally, we use a super efficient heat pump to boost that temperature up to a level that can heat our homes and businesses. And this is the magic number. This is what makes the whole thing so incredibly efficient. Because you're starting with 20-degree water, the heat pump gets this enormous head start. For every 1 kilowatt of electricity you use to run the system, you get 3 kilowatts of heat energy back out. That's a fantastic return. And listen, this isn't just some wild idea on a whiteboard. It's a technology that's being rolled out right now. The old coal fields of the UK are literally becoming the new hotbeds for green energy. And just think about the scale of this for a second. It's massive. A full quarter of all homes in the UK are sitting right on top of these abandoned coal fields. The heat source is right there, exactly where the demand is, in the very communities that coal once powered. And look at the projects already happening. In Gateshead, a new district heating system is going to warm 300 buildings, everything from homes to concert halls. A company called Lanchester Wines is using it to heat a massive 1 million square foot warehouse. And over in Durham, a whole new village of 1,500 homes is being built to run on this exact technology. And when you put it side by side with natural gas, the benefits are just stark. I mean, look at this. Carbon emissions are only about 7% of what you'd get from gas. The source is local and renewable, not imported and fossil-based.
and it cleverly repurposes infrastructure that's already there. It's a win, and a win.
So the potential is obviously huge, and we know the technology works. So what's next? What are the challenges we still need to overcome to unlock this vast energy source? Now, we have to be realistic here. It's not a silver bullet, not yet anyway. The drilling rigs often run on diesels, so there's some embedded carbon. You can run into technical issues like a rusty iron gunk called ochre that can clog up the pipes. And the upfront investment is pretty significant. That Gateshead project alone costs around £60 million.
But man, if we can overcome those hurdles, the prize is just immense. We're talking about over 23,000 abandoned mines in the UK alone. And inside them, an estimated 2 billion cubic meters of geothermally heated water. It is one of the country's largest, most stable, and most underused sources of clean energy, period.
And that brings us to the final lingering question, doesn't it? The technology works, the resource is absolutely enormous, and it's located right where people actually live. It literally turns a historical problem into a modern solution. So the real question is, with all this energy right there, just beneath our feet, why aren't we all using it more?